So this entire network, which we represent just as a globe or something, is actually built by different types of devices. In this video, what we're going to understand and identify is what all are the different types of devices that are needed for building a network. And it really depends. It depends on the need of the network. It depends on the need of the user. It depends on various factors that we employ different types of devices here, and there is a variety of devices that actually makes this network up and running, and at the same time there are devices that are actually making it secure as well. So we are going to go in depth on each of those devices and how these devices come together to build the network and secure the communication that is actually happening in the network. But before we go into that, in this short video, that what we're going to see is what all are the factors that really drives what is the device that needs to be selected. The selection of the device itself is driven by a set of factors, and now we are going to see what all are those factors in this video. So let's get started. The first part or the first factor could be, how far is the endpoint. For example, let's say you are in a room and you are having a laptop and you are sitting along with your friend and you want to communicate with each other. You just need a cable for you to connect between, or it could be a Wi-Fi access point, and we are going to go over each of these devices. You might have heard of these devices, but you might have heard of these devices as a end user, right? I mean, as a user, you might have heard of the devices. You might not have, as a student or say a network engineer or an administrator who actually builds this network and maintains this network. He need to look at these devices in a separate lens altogether. So we are going to get there, but do understand that how far the endpoints are, the distance, the geolocation of two endpoints that are trying to communicate with each other. Depending on that, you will have different devices. If you are in a room, you will use a Wi-Fi or a cable, or you may use something called a hub or a switch. If you are in two different continents, then there are multiple devices that are actually coming into play. It will start with your Wi-Fi router or a switch, and then it will go all over the way to tier 1, tier 2, tier 3 ISPs, and then it actually gets hand off at the same other end, whom you are actually communicating at the other end. We'll go over it, but do understand that how far these devices are communicating, depending on that, we will need to employ different types of devices to build the network. The another factor is the latency required. Let's say in this case is it is not the devices that are actually communicating. Let's say a user is trying to access an application, and that application, an application, when an application developer develops an application or architects an application, that point in time he actually defines what all are the latency that is actually required. A simple example would be, let's say a voice application that you are actually hearing somebody, the audio that is actually transmitted from very long distance, right? It's very important that these messages of audios, these packets of audios are actually coming in a very latency sensitive manner, because if there is a lag, then it is going to affect the way you hear those voice. So the latency is one of the factor, and along with latencies comes the bandwidth, the jitter that really impacts an application. What is latency? We identified bandwidth is basically what is the minimum bandwidth. You might have heard, like when you go to an ISP, they say like, I can give you 100 Mbps or 200 Mbps or 50 Mbps. That's actually for the home use. Now, how do you decide for an application to work? That application, for whenever there is an application that is getting built, that application developer is going to tell that this particular operations that has to be done in this application, you need minimum of so and so bandwidth. For example, Netflix, it require a higher bandwidth because it's actually streaming high quality video, an example, right? So latency, also the bandwidth, also jitter, that kind of stuff actually really matters on what kind of devices you need to employ, because for that device, for that application to serve the purpose, it may need multiple devices as such. Another is, what is the budget allocation for running and maintaining your network? For example, let's say you are an administrator sector of a large enterprise, and there are multiple sites, and these multiple sites has to be connected. So there are multiple ways to connect these sites. It could be a leased line, which is a cable directly pulled in. It could be a technology like MPLS. It could be even a broadband. So depending on the budget, and for each of this technology to be involved, there is a budget related to it. And for each of once you finalize what is a budget and what is the type of technology you want to use, depending on that, we will be using different types of devices in each of those sites for the connectivity purpose. So budget and budget allocated for running and maintenance of your network is the next one. Another important piece is how many connections per second that you are actually trying to see. For example, let's say a retailer like Amazon, or Walmart, or somebody who's actually online who purchases. There will be huge amount of purchases when there is a holiday period like Thanksgiving, Christmas, or even if it is a site where there is some government related stuff and there are a lot of people trying to access and get the information. That means what are the number of underlying connections that is actually this application needs to, or this transaction needs to handle. Depending on that, we will be employing different types of devices, maybe a load balancer, maybe some kind of multiple devices for balancing the number of connections, and stuff like that. So that total number of connections per second is one of the key factor to identify what device needs to be employed for this network to be up and running. Another piece is what is the type of device that is actually accessing and communicating. For example, if you are accessing an application through your mobile, which is pretty common nowadays, in that case, we would need the technologies like 3G, 4G, or 5G. We call it as a radio access network. That's the kind of technology that we need to employ. Wherein, on the other side, if you're trying to access the same application using your laptop, you don't need the RAN, a radio access network, but you would need again a Wi-Fi router or a switch which is able to connect to the ISPs, and then ISPs, which is the service providers, will be able to help you connect to that particular application. So type of device and type of the end points that are trying to communicate is another factor that depends on how and what devices to be employed for building the network. And last but not least is the level of security that is needed for the sessions and transaction. For example, there may be some, your personal data that is being filled and that is being transmitted for authentication purposes, or there may be some confidential data that your company has to store in a specific location. So how do you kind of store this data in a specific location with total security? And at the same time, I also make sure that whoever is accessing my data, even that is actually kind of secure. Depending on that, you may employ a firewall and multiple features in a firewall. This list of factors that we see here is by no means the entire list. This is basically a very, very, very high level list of items that we need to consider, and depending on that, we will be deciding what all types of devices that is needed for building a network. Now in the subsequent session, we are going to see different types of devices, and we will come back to this set of factors, and then we will see what device is the right device to be employed for building your network. Thank you.